Hi everyone. Now, you might not recognise me because of my big fluffy hair and my recent rushed shaving injuries, but it's Mr. Todd. I've really been enjoying reading your emails and seeing all the lovely home learning you've been sending in recently. I've had a few emails about the White Rose Hub home learning we've been sending out to you, and their problem solving especially. So I thought I'd do a few worked examples for you so you can see how we might approach them at school, and hopefully that'll help you with the next time you come up with some of these problems. Let me just figure out how to flip a camera around and we can get started. So this was some of the Year 6 activities, problem solving activities from a week or two ago now. I'm just going to go through number one with you now. The White Rose are really big fans of something called bar modelling, which you can find more out about on their website or just by a Google search really. And I'm going to show you maybe a slightly different version of the bar modelling, just because I think it might make it a bit clearer over video for you. And I just want to talk about how we can draw the problem, okay? If you can draw the problem, if you can see what it means, if you can even recreate it with some different things you may have at home, it can help your understanding of it so much, and suddenly things will click for you. So it's a really good thing to be able to draw problems or just be able to represent them in different ways. So here's my first problem. A car park is full, a third of the cars leave, 60% of the remaining cars are red. There are 174 red cars. How many cars left the car park? Now, this is a really challenging question. The maths in it isn't too bad. We know how to find thirds. We know how to find percentages. Hopefully we can count up to 174. I don't think many of you have that many fingers though. If you do, something's slightly worrying there. So the maths in it isn't actually that hard, but it's the language and thinking about what it's actually asking you to do. So to get me started, I'm just going to draw a car park. Here you go. Here's my very fancy car park I'm going to start drawing. Yes, I know I'm drawing in pen, soaps and base. You don't need to send in angry emails. I just thought it might be a bit clearer for you on YouTube to see. So here's my car park. It's very long and thin. And we don't know how many cars are in it yet. That's fine. Or how many cars have left or anything. That's fine. It tells me that a third of the cars leave. So a third is about there. So therefore, this bit here is a third. This bit here, this part here, is 2/3. So the whole is 3/3 of just one car park that I've got there. I know a third of the cars leave, so I'm going to write leave here to remind me. You got there? And then there you go, that's that first bit done. Now, the next bit says 60% of the remaining cars are red. So the remaining cars are this section here that I've got. So red cars needs a red pen. 60% would be, I don't know, about there. Doesn't have to be too accurate. We're not doing it to scale or measuring it out. This is just to help me see it in my head. So this here is my 60% of my red cars that are remaining. It tells me down here there's 174 red cars. So I could put 174 there, and that's going to help me to see what's going on. From this, I can tell that 60% of these remaining cars are red, and that is 174 cars. Okay, so we can then figure out what all the remaining cars are by finding out what 100% of the remaining cars would be. So I know from my times table facts that 10%, I'd have to divide 60 by 6, so I'm going to divide 174 by 6, which is 29. Therefore, 100% of the remaining cars is going to be 290, because I just times 29 by 10. Okay. Therefore, all of this bit here, I've run out of space, I'm going to have to cross out that bit a little bit, is 290. So 290 cars were left in the car park that I've got here. That's this section here. Not all of them are red, but they're 290 cars. Okay. If I know that 290 stayed in the car park, and I know that that is 2/3 of the number, then I can figure out what 1/3 is going to be. If 290 is 2/3, then 1/3 is going to be half of that. It's going to be 145. Okay, so 145 cars left the car park, which will be your answer. And from this really quick, slightly long and thin, strange picture of a car park, I can see as well that in total there were 290 and 145 cars in that car park to start with. So it doesn't have to be anything official. It doesn't have to be a formal diagram drawn with lines, with ruler lines, I should say, or anything like that. It's just a few notes that helps me figure out and see what's happening in my head. Now, this problem, also from the same Year 6 task, is a really difficult problem as well. Again, the maths isn't too bad. It's a bit of money and it's a bit of ratio. And you can draw this out. You could use coins themselves to try and make this work. If you actually emptied out your piggy bank, I'm sure you'd be able to find enough 20p's and 10p's to help you figure this out as well. Okay. So in total, I'm going to need to find £6 and 5 pence. I'm going to write that top so I don't forget. And I can use 20p, 10p and 5p coins. Okay. It says for every 2 10p coins in the box, Eva has 1 20p coin and 3 5p coins. So if there's 2 10p coins, here you go, here are my very fancily drawn 10p coins. Every 2 10p coins that she uses, she's going to use 1 20p coins are a bit of a hexagon or something, aren't they? Maybe not, maybe got more sides than that. And 3 5p coins. 5p coins are the smallest coins. Here you go. So for every 2 10p coins, she has 1 20 and 3 5p coins, okay? What I could do now, I'm going to count this up. So if it's 10 and 10, that's 20, that's 40, 45, 50, 55. So that equals 55p. Now, I could keep counting up from 55 until I get to £6.5. I could then go, right, there's another 210. If there's 210, I've lost my green pen. If there's 2 10p coins, there's going to be 1 20p coin. There's going to be 3 5p coins. That's another 55p. So in total now, I've got 55 and 55, which is £1.10. And I could keep counting up. It would help if I put the camera in the right place, wouldn't it? So you can see. And I could keep counting up. It's going to take me quite a long time to be able to add all those coins though. What you could do is just think about counting up in your 55s, or maybe even thinking about some of our number facts that could help us. I know that 55 times 10 is 550, okay? I know that another lot of 55 is going to get to 605. If it's one more lot of 55, that's going to be 55 times 11, okay? So I know that 11 times 55 is £6.05 or 605 pennies, whatever you want to say, or however you want to think it. So that means I must have 11 of these groups that are going to add up to £6.05 or 605p. So if I've got 11 of these groups, I've got 11 lots of this, so I'm going to have 11 lots of 2, which is 22 blue coins. I'm going to have 11 times 1, 11 green coins. And then I'm going to have 11 times 3, I'm going to have 33 5p coins. Okay, so there we go. That is how much of each coin Eva has in her money box, which is probably going to be quite heavy by the time she saves up all that money. I hope that helped. I hope that's going to give you some hints and tips for maybe approaching your problem-solving activities next time. I really recommend drawing them out, just doing some little scribbles, anything that just helps you visualise it in your mind. Maybe get out some coins, maybe get out some different items that you can count up or sort or organise. And hopefully that way you'll start to see those patterns and you can use all the maths that we know you can do and apply it to these problems. And you can feel really proud because these problem-solving activities are really hard. So if you can work your way through them, you're doing a really good job. Keep going, keep in touch and show us some really good examples of the problems you've solved. And please feel free to ask any questions you need as well. Cool. See you later.